Hello, good afternoon, everyone. Can everyone hear me?
Good afternoon, sir.
Yes, good afternoon.
Good
Shabbarna,
afternoon,
Smriti.
sir.
Good afternoon, good afternoon. Okay, good afternoon, Rupkatha. Can you hear me? Rupkatha, Aditi,
Yes,
Abhishek,
sir. Good
Abhini.
afternoon,
Yes,
sir.
sir.
Yes,
Okay,
sir. Good morning. Good afternoon.
Yes, sir.
Good afternoon.
okay, okay.
Good afternoon, sir.
Yes, good afternoon, Abhini. Okay. So, everyone, how was your school exam? Maths exam? Tell me how much you scored. Tell me, Rupkatha. I'll start with Rupkatha. Tell me how much you scored in maths in school.
77. 77.
2 times 77. Hmm? Rupkatha?
Yes, I think no, previous time I did not get 77. Previous time I got 78, I think. I don't remember clearly, but yeah, this time I got 77.
Lost 1 marks. Why? What happened?
I lost 3 marks. Like I got 77. So
No, before it
uh,
was
I
78.
did a mistake in there was a trigonometry sum.
Okay.
Yes, this time I got 77. So I lost like 2 marks in a trigonometry sum. There was a proof with from trigonometry. I lost 1 mark there, and in coordinate geometry there was a graph drawing. So I plotted one of the points wrong. So I lost 1 mark there.
You should have scored full. You try to score full in school exam. Divine, tell me how much you scored.
Yes, sir.
Oh, Divine,
Sir, I got 78.
then why not full, Divine?
Sir, in trigonometry, for one step, teacher cut marks because I did not show the square. That's why. There 1 marks and one MCQ was wrong.
Okay, try to score full, Divine. Try to score full. Okay, in school exams. Aditi, tell me how much you scored.
Sir, in half yearly it was 79 and this time it's 80.
Oh, this time full. Very good. It's full, right?
Yes,
Or
sir.
80, 80 out of 100, no, right? Or 80 out of 80.
Sir, 80 out of 80 and unit test it was 19. 19 out of 20, sir.
Hmm. Okay, nice. So total it would be 99, not 100, right?
No, sir.
Okay. That's good. Maintain this. Okay.
Yes, sir.
Yes. Okay, Aditya, how much you scored in school?
Sure, 73.
Se- 73. Why so less? What happened?
So, I did both of the questions that I got wrong for 4 and 3 marks. I did silly mistakes. In one question, there was a question about surface area and volume. We had to find out the cost of paving the sidewalk. Yeah, and instead of getting 346.5 as the area of the sidewalk, I got 345.5. So my cost also went wrong. So the entire 4 marks is gone. And another one was a trigonometry problem. I did one of the relations wrong. So the whole 3 marks.
Okay, see to it that you are scoring full in school exam. Okay. It's not acceptable, Aditya. Okay.
Yes, yes,
Try to
sure.
score full in school. Okay. Next, Snehatra, how much you scored?
Sir, this annual examination I don't know because I didn't go to school today, but half yearly I scored full.
No, I'm not talking about half yearly. I'm talking about finals only. Okay, let me
I'll,
know.
I'll
Snehatro, you got 80
Oh,
only.
Snehatra got it. Okay, so how come Abhishek, you know his marks?
Because sir told
Okay, okay. How many people got 80 in your class, Abhishek?
many,
Many.
like 3, 4 people, 5 people like that.
Okay, okay. You are amongst them, right?
Yes, yes.
Great. Abronil, how much you scored?
Sir, results have not been declared yet.
Not been declared yet. Okay, let me know once it is
Okay,
declared.
sir. Okay, sir.
Okay, Sampurna, how much you scored? Sampurna Samriddhi,
Sir, I got 63.
out of
80.
and Samriddhi.
Sir,
65.
results have
Si-
not been released.
No, no, wait. Not you, Samriddhi. Actually, there are two people in Sampurna's account. Okay, So, anyways, but try to score full. Okay, you have to improve yourself, both of you. Is it clear?
Yes, sir.
Okay. So next, Samriti, your results is not yet declared, right?
No, sir.
Okay. Whenever it is declared, let me know. Okay.
Okay.
Okay. As Bhargav also results are not yet declared, right?
Yes.
Okay. Devopriyo.
Sir, 79 out of 80.
Okay. Okay. Where did you lose 1 marks?
Sir, MCQ1 means where we said means vertices I compare with edges and I don't vary.
So they were asking you the number of vertices
No,
instead
no.
of that.
After that, they were asking on the perimeter of the first face, and I multiplied two. Means there should be four, right?
Don't make such mistakes.
Yes, sir.
Okay. Next is Twanil.
Sir, result have not yet been declared.
Okay. But how much are you expecting?
Sir, above 75 out of
Above
80.
75. Should be full, right?
Yeah, yes, sir, I expect.
Okay, let's see. Okay. Okay, Kaustav, how much you scored?
So I got four.
Full, very good. Very good. Okay. So there is one more person. Yes, Aman. Aman, how much you scored?
Yes, sir, full.
Full, very good. Very good. So anyways, so everyone, today is our first class of this session. Okay, I'll be starting with a new chapter of class 10. Okay. And today I'm going to start with real numbers. Okay. This year, I hope many people participate in IQM, okay, and try to score better. Very soon, I'll be starting IQM classes also, okay. I'll let you know, not now, okay. And Sampurna and Samriddhi, since this is your first class, okay, you people have to send your answers in WhatsApp. Okay, once you have done it, you have to send your answers in WhatsApp only. Is it clear?
Okay, sir. Okay, sir.
Okay, so everyone, let us start. Okay, today we are going to discuss real numbers. Okay, can everyone see my screen?
Yes, sir.
And if you people have any doubt, you have to raise your hand, as we all know. Okay, without raising the hand, don't speak up. If you have any doubt, raise your hands and now. Okay, real numbers, let's start. Okay, so let's start with what is say. First of all, you people know there are some predefined sets. Everyone knows what a set. Okay, first of all, we have natural number set. Above this, we have whole numbers. Okay, above this, we have integers. Above this, we have rational numbers. Okay, and above this, we have real numbers. Okay, so real numbers is actually the superset of all the sets. Okay, rational numbers, integers, whole numbers, natural numbers. Now, the set which is not rational, okay, the set of numbers which are not rational but it is real, they are irrational numbers. Okay, as we all know, like square root of 2, square root of 3, cube root of 4. Okay, all these numbers are irrational numbers. Okay, above this also we have another set. Okay, which we'll learn it in class 11, that is complex numbers. Okay, so complex numbers, the superset of all the sets. Okay, it is a superset of all real numbers also. Okay, I'll explain why, you'll understand. Okay, next. So first of all, I'm going to define what are factors. Kaustubh, tell me, you were saying something.
Yes, sir. So how do we express express complex number using C?
Yes, we present complex numbers using C. Next, first of all, I'm going to discuss what are factors. Okay, this is the correct definition, standard definition of factor. Like if A is a factor of B, if A is a factor of B, okay, then there exists a natural number n, and there exists a natural number. Remember, natural number n such that A multiplied by equal to B. So, for example, 2 is the factor of 18. So, 2 is a factor of 18. Since 2 multiplied by 9 is equal to 18 only. Okay. Next, you people can also think like minus 2 is a factor of 18, right? You will say that minus 2 can also be a factor of 18. But what do you think? Will we get any natural number that should be multiplied by minus 2 such that it becomes 18? Tell me, what do you think? Can we get any natural number? Yes, Kaustubh, tell me.
No, sir.
No, because over here it should be multiplied by minus 9, then only we'll get 18. Okay, so that is why minus 2 will not come under the set of factors of 18. Okay, minus 2 combines 18, but we cannot say minus 2 is a factor of 18. Okay, for factors it should be strictly natural numbers. Okay, number one, multiples. Yes, for multiples, if A is a multiple of B, if A is a multiple, okay, there exists, then there exists a natural number n. There exists a natural number n such that d multiplied by n is equal to a. No, the number of multiples, the number of multiples of, or say the number of multiples of any natural number, the number of multiples of any natural number is always infinite. Is always infinite. While the number of factors, while the number of factors of a natural number is always finite. The number of factors is always finite. Okay. I'll give you an example, you'll understand. It's always finite. Like for example, okay, let us write down the factors. The factors of 36 are, factors of 36 are 1, 2, 3, 4, 6, 29, then 12, 18, and last 36. Right. These are the factors of 36. Okay. But what are the multiples of 36? You see, if I want to write multiples of 36, okay, it goes on and on. Okay, at till infinity. Multiples of 36 are 36 and 72. Okay, and so on. It keeps on going. Okay. So see, multiples of 36 are infinite. Okay. Number one, you also note that zero has infinite divisors. Okay. Zero has infinite divisors. Okay. It is divisible by infinitely many numbers. Okay. Next. Like they can ask you, zero is the only number which has infinite divisors. Okay. Whereas other numbers, they have finite number of divisors. Okay. But zero has infinitely many divisors. Next. HCF or GCD. HCF or GCD. So greatest common divisor. So basically largest common factor. Largest common factor of a given number of 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 given numbers is the GCD. Is there GCD? Okay, denoted by. Okay, how it is denoted? A GCD of A and B. GCD of A and B is denoted as GCD of A and B is denoted as first bracket A comma B. Whenever I'm writing A comma B first bracket, over here in number theory it means GCD. Yes, opponent, tell me.
Sir, your voice is cracking a little bit.
It is cracking for everyone.
Yes, sir.
Yes, sir.
Yes,
No,
sir.
Yes,
sir.
sir.
Okay. Okay, just give me 1 minute. Hello. Hello. Now is it fine? Can everyone hear me now properly?
Yes, sir.
Yes,
Okay.
sir.
Okay. Okay. Okay, let us continue. Next is LCM. Okay, least common multiple. It's the smallest positive number. The smallest possible number. The smallest possible number. That is a multiple of the given numbers. That is a multiple of the given numbers is their LCM. Is their LCM. Okay. Next, if n is equal to LCM of A and B, if n is equal to LCM of A and B, okay. So can I say that n can be written as A multiplied by K, and I can also say n can be written as B multiplied by some L, where K and L belongs to integers, where K comma L belongs to integers. Okay. That is, LCM should be LCM should be an integral multiple. LCM should be an integral multiple of those numbers. Okay, LCM should be an integral multiple of those numbers, where GCD of K and L will be equal to 1. Okay, this I'll prove it later. Later on, I'll prove it why the GCD of K and L will be equal to 1. Okay, wait for some time. For example, So somebody tell me, you have to raise your hand. Everyone knows LCM of 2 and 8 is equal to 8 only. Okay. Next, what is the LCM of 12 and 18? Raise your hands. What is the LCM of 12 and 18? Yes, Sampurna, tell me.
36.
36. Okay. Next, somebody tell me what is the LCM of 1 and square root of 2? Raise your hand. What is the LCM of 1 and square root of 2? Yes, Pranil, tell me.
The square root of 2.
No, it's not correct. Okay, Kostov, tell me. Sir,
Sir,
everybody
I was
has put
about to
up.
say that. I was about to say that.
Oh, you are about to say that only. Yes, Bhargav, tell me.
Sir, 2.
Oh, no, that's not correct. Okay, Aditi, tell me.
Sir, I also have the answer too.
Two, acha. Abramil, tell me.
Sir, 1.
One, no. Samriddhi?
Sir, is it possible?
It doesn't exist.
Yes, yes, yes. So Samriddhi, I think Samriddhi has given the answer, right? Does not exist.
Yes.
Sir, it's Sampurna.
Sampurna, acha, Sampurna gave. Does not exist. Exactly. So I'll tell you why it does not exist. You will understand. Okay. So at first, I think somebody told me root two. Right. Tell me. It looks like yes, the LCM of one and root two is root two. But the problem is you have to ask yourself, is root two an integral multiple of root two? Tell me.
No,
Yes, root two is yes, root two is an integral multiple of root two. Right. Cost of root two into one is root two.
yes, but
But
not 1 is to root 2.
is root two an integral multiple of one?
No.
No. Okay. So you won't be able to find any number which is an integral multiple of both the numbers. Okay. So that is why LCM of 1 and root 2 does not exist. Is it clear to everyone? But although while simplification will take LCM of 1 and root 2 is root 2 and we simplify fractions. Okay. But generally LCM of 1 and root 2 does not exist. Yes, Pranil, tell me, you are asking something.
Sir, can you raise the screen up a little bit?
Over here.
Yes, sir.
Okay.
Okay, sir. Okay, sir.
Okay. So you can write it down. Since square root of 2 does not belongs to integers. Okay. LCM of 1 and root 2 does not exist. Okay. Next, somebody tell me what is the LCM of 2 and pi? Raise your hands. What is the LCM of 2 and pi? Yes, Aditi, tell me.
So 44 by 7.
No,
You said 22 by 7.
Yes, sir.
no, no. Again, raise your hand. Don't speak up in between. What did I say, Kostov? Yes, Samriddhi, tell me.
Sir, this doesn't exist either.
Yeah,
Yes.
yeah, it doesn't exist.
Oh, actually, there are two Samriddhi. Okay, so I'll call Samriddhi Debnath at Samriddhi 1 and Samriddhi Banerjee at Samriddhi 2. Okay,
Okay, sir.
in order to so that there is no confusion. Okay, so LCM of 2 and pi also does not exist because pi is an irrational number. Okay, try to understand. Pi is an irrational number. Okay. Yes, good afternoon, Koshani. Can you hear me?
Yes, sir.
You joined so late. What happened? Similarly, LCM of a rational number and an irrational number does not exist. Is it clear to everyone? Remember, if there's anyone having any doubt, you can ask me now. Next, problem everyone. Question number one. Once you've done it, send your answers in WhatsApp. Find the LCM of find the LCM of 2 pi and 3 pi. Question number two. Find the LCM of find the LCM of root 2 and pi. Once you've done it, send your answers quickly. Yes, Aman, number 1 is correct. Snehadara, both are correct. Bhargav, both are correct. Sampurna, Samriddhi, both are correct. Okay, Aditi, number 1 is correct. Kaustav, both are correct. Aditya, both are correct. Debayan, first one is correct. Devopriyo, both are correct. Samriddhi, 1. Number 1, you have to check. Rupkatha, both are correct. Debayan, number 2 is correct. Tonil, number 1 is correct. Okay. Aditya, both are correct. Tonil, number 2 is correct. Aman, number 2 is correct. Yes, Abhinil, both are correct. Aditi, number 2 is correct. Number 1 is correct. Kaushiki, both are correct. Ashani, both are correct. Yes, Samriddhi, 1, number 1 is correct. Okay, so number 1, everyone has got correctly. LCM of 2 pi and 3 pi is equal to 6 pi. Okay. And number 2, root 2 and pi. You won't get any integer such that, you won't get any real number such that it is an integral multiple of both root 2 and pi. So it does not exist. Yes, Samriddhi 1, your answer is correct. Does not exist. Okay. Next, LCM of fractions. LCM of fractions will be equal to LCM of numerator. LCM of fractions is equal to LCM of numerator divided by LCM of denominator. Sorry, HCF of denominator. Okay. LCM of fractions is equal to LCM of numerator divided by HCF of denominator. Okay, next, HCF of fractions. HCF of fractions is equal to HCF of numerator divided by LCM of denominator. Remember. For example, if I want to find out the LCM of 2 by 3, 5 by 9, and 12 by 17. This will be equal to LCM of 2, 5, and 12. LCM of 2, 5, and 12 divided by HCF of 3, 9, and 17. So people can understand LCM of 2, 5, and 12 will be equal to how much? 60. And divided by HCF of 3, 9, and 70 will be 1. So it will be 60. Remember. Okay, there shouldn't be any confusion. Next, properties of HCF. Properties of HCF. Number 1, HCF of two numbers, A comma B, is always greater than or equal to 1. It can never be equal to 0, okay, or less than 0. So it is always greater than or equal to 1. Next, number 2. HCF of two numbers, A comma B, will be equal to HCF of mod of A comma mod of B. Okay. Next, for example, HCF of minus 12 and minus 18 will be equal to HCF of 12 and 18 only, which is equal to 6. Okay. So is my voice cracking now? It's fine, right? Everyone can hear me properly?
Yes, sir, it's fine.
Okay.
Yes,
Okay.
sir.
So next, number 3. So what is HCF of A and 0? Means if I want to find out the highest common factor of A and 0, raise your hand. Somebody tell me. What do you think? What should be the highest common factor of A and 0? Okay. Of course, for A not equal to 0. Of course, for A not equal to 0. Yes, Bhargav, tell me.
Sir, A.
Actually, mod of A. You are correct only. Mod of A. Because A can be negative also. Okay. So it will be mod of A.
So how, sir?
You need to find out the highest number which is divisible by both. I mean, which divides both. Not divisible by both, which divides both. So tell me, what
Yes,
can
sir.
it be? It has
8.
to be A.
8.
A. Okay. A divides both A and 0. Next, number 4. HCF of A and B will be equal to HCF of A plus KB, comma B. Okay. For some K belongs to integers. Okay. For some K belongs to integers, HCF of A and B will be equal to A plus KB. Okay. For example, HCF of 12 and 18 is equal to 6. Okay. And HCF of 12 plus 2 into 18, comma 18 is also equal to 6. Okay. That's number 5. HCF of A and B is also equal to HCF of B and A. Okay. Next, number 6. For any non-zero, for any non-zero m belongs to integers. For any non-zero m belongs to integers, GCD of MA comma MB will be equal to mod of m into GCD of A and B. For example, GCD of 36 and 24 will be equal to, you can take any multiple out, okay? It will be equal to 12 into GCD of 3 and 2. It is also equal to 6 into GCD of 6 and 4. Okay, they all are same. Next, number 7. If GCD of A and B is equal to G, then GCD of A by G, comma B by G is equal to 1. Okay, like for example, again, GCD of 36 and 24 is equal to 12. And if I want to find out the GCD of 36 by 12, comma 24 by 12, it will be equal to 1. Okay. Next, number 8. If GCD of A and B is equal to 1 and GCD of A and C is also equal to 1, okay, then GCD of A comma BC is also equal to 1. That is, if A and B does not have a common divisor, common factor, and A and C also does not have a common factor, then A and the product of BC will also not have a common factor. Like for example, GCD of A and BC, sorry, GCD of 2 and 3 is equal to 1, and GCD of 2 and 5 is equal to 1. But see, GCD of 2 and 3 multiplied by 5 This is also is equal to 1. Okay. Achha, somebody tell me. Over here, GCD of A and BC is equal to 1. Okay. Is it true that GCD of AB comma C is also equal to 1? Tell me. If GCD of A and B is equal to 1, GCD of A and C is equal to 1. Can I say GCD of AB comma C is also equal to 1? Raise your hand. You have to give me counter example or you have to prove it. Tell me. Yes, Aman, tell me. Can I say GCD of AB comma C is equal to 1?
No, sir, because if B and C have a common factor, like suppose if we take 2 and 21 and 2 and 63.
Correct, correct. 2 and 21 and 2 and 63. You see, everyone, GCD of 2 and 21 is equal to 1, and GCD of 2 and 63 is also equal to 1. But see, 2 multiplied by 21, that is 62. Oh, sorry, 42. 42 comma 63 is not equal to 1. Okay. So GCD of AB comma C will not be equal to 1 because B and C can have a common factor. Okay. Next. The next one is very important. Number 9. Very important. If GCD of A and B is equal to G, then there exists then there exists two integers x and y, then there exist two integers x and y such that ax plus by is equal to g. Okay, everyone. For example, you see GCD of 2 and 5 is equal to 1. Okay, and you will see 2 into minus 2 plus 5 into 1 is equal to 1. Okay, GCD of ax plus by will be equal to g. Okay, I'll prove this, you will understand. Next, number 10. LCM into HCF is also equal to product of two numbers. LCM into HCF is equal to product of two numbers. Okay. Next, number 11 is derived from number 9 only, that is Bezout's identity. Okay, this is also very important for Olympiads. Okay. Questions from this identity has come in the past in IQM. Okay, Bezout's identity. If GCD of A and B is equal to 1, then there exists some integers n comma m such that am plus bm is equal to 1. Okay, so let us see the proof. Okay, I'm going to prove 9.
Sir, will you please show 5 and 6? I cannot copy them.
Okay, copy quickly.
Yes, sir, done.
Done. Okay, so I'm proving number 9, everyone. Okay, number 11 will follow if g is equal to 1. Okay, so everyone, for example, okay, let us see the proof. Proof of number 9. Okay, comma 11 you can say. They both are same. Just g is equal to 1. So everyone, if D is equal to GCD of A and B, if D is equal to GCD of A and B, yes, Abhishek, tell me. You're saying something?
Sir, isn't the 11th one just a repetition of the like ninth one? Ninth one.
Yes, 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 yes. Okay, these are for co-prime numbers. Okay, that is why I have written it separately as an identity. Okay, these are for co-prime numbers. GCD of AB is equal to 1. Okay, if D is equal to GCD of A and B, okay, everyone, if D is equal to GCD of A and B, can I say that D divides A? Tell me. And D divides B. Tell me, everyone. when I say that D divides both A and B, okay, so this implies there exists some integers. There exists some integers. There exists some integers x and y such that there exists some integers x and y such that ax is equal to sorry such that d divides ax plus by. Yes or no? Tell me everyone. If d divides a, then d divides ax also, and if d divides b, then d divides by also. So d divides sum of them, ax plus by. Okay. So if d divides ax plus by, okay. So for some integers, for some natural number, k, d will be equal to, sorry, ax plus by will be equal to k into d. Yes or no? Tell me. For some natural number k, ax plus by is equal to kd. Yes or no? Means it will be a multiple of d. Now tell me, what is the least value of k? Least value of k is equal to
1.
1. Okay. This implies ax plus by is equal to 1. Hence proved. Tell me, is it clear to everyone? If there's anyone having any doubt, you can ask me now. For some integers x and y, k can be equal to 1 also. Yes, Devapriya, tell me.
Sir, it should be 1 or D.
Oh, D. Sorry. D.
Okay, sir.
Okay. Yes. So tell me, anyone having any doubt? Has everyone understood the proof? Tell me. If there's anyone having any doubt, you can ask me now. Yes, tell me, Abhishek, Aman, Bhargav, everyone understood? Kaushani, is it
Yes,
clear?
sir. Yes, sir.
Yes,
Yes.
sir.
Okay. So everyone, let us do some problems. Question number 3. The LCM and HCF. The LCM and HCF of two numbers are are 168 and 12 respectively. If their difference is 60, find their sum. Solve. If their difference is 60, find their sum. Question number 4. The product of two numbers. The product of two numbers is 6760 and their HCF is 13. And their HCF is 13. How many such pairs can be formed? How many such pairs can be formed? Okay. The product of two numbers is 6760 and their HCF is 13. How many such pairs can be formed? So once you have done it, everyone quickly send.
So what is meant by how many such pairs can be formed?
Uh, how many such pairs exist such that their product is 6760 and HCF is also 13?
Oh, okay.
The Koshani number 3 is correct. Snehatara 3 is correct. Abhishek, this is the answer of 3. It is correct only. Yes, Kaushiki 3 is correct. Samriddhi 1, 3 is correct. Okay, let me start with number 3. It's written that the LCM and
I'm
HCF.
sending it.
Sending? Send. Yes, Costa 3. No, I think this is Rupkotha. Rupkotha 3 is correct. Yes, Costa 3 is correct. Tonil 3 is correct. Divan 3 is correct. Abhunil 3 is correct. Okay, let me start with number 3. Okay, so everyone, it is given that the LCM and HCF of two numbers are 168 and 12. If the difference is 60, we need to find out their sum. Tonil number 4 is correct. So everyone, since their HCF is 12, yes, Bhargav number 3 is correct. Since their HCF is 12, can I say let the numbers be? Let the numbers. Yes, Aman number 3 is correct. Let the numbers be 12A and 12B. Okay, since their HCF is 12, let the numbers be 12A and 12B. Okay. Yes, Koshani number 4 is correct. Then we can say that LCM into HCF, Snehadara check number 4, is equal to the product of two numbers. Right. LCM into HCF is equal to product of two numbers. Okay. So from here, what are we getting? 168 into 12 is equal to 12A into 12B. Okay. This implies 12 gets cancelled. Product of A and B will be equal to 168 by 12, which is equal to 14. AB equals to 14. And it is given in the question that there's sum we need to find out. And the difference is given to us. That is 12A minus B is given as 60. So this gives us A minus B is equal to 5. So I've got A minus B is equal to 5, AB equal to 14. I need to find out A plus B, 12A plus 12B. Okay. So everyone, we can square both sides to find out the sum. This implies A minus B whole square is equal to 25. This implies, A minus B whole square, we can write it as A plus B whole square minus 4AB is equal to 25. This implies A plus B whole square minus 96 is equal to 25. So from here, A plus B whole square is equal to 96 plus 25, which gives us 121. So everyone, I'm getting A plus B is equal to 11. Okay. So I've got A plus B is equal to 11. Wait, let me see.
Sir, won't 4AB be 4 into 14?
Oh, sorry. I'm making a mistake. It should be 56. Sorry. So it is 56 plus 25, which is equal to 81. Sorry. This gives us A plus B is equal to 9. Okay. So I've got A plus B is equal to 9. I need to find out 12 into A plus B. Therefore, their sum. Sum is equal to 12 into A plus B, which is equal to 12 into 9, which is 108. Is it clear to everyone? It's very simple. Okay. Tell me, Sampruno, Samriddhi, is it clear?
Yes, sir.
Aditi, have you understood?
Yes, sir.
Okay.
Sir, can you show me number 4?
Yes, everyone solve question number 4. A product of two numbers is given to us. Okay, let me see. Snehatara, check number 4. Okay, Aditya, number 3, have you understood?
Yes, sir. I forgot to multiply 12.
Okay. Abhishek, number 4 is correct. Samriddhi, 1, number 4 is correct. Rutkatha, 4 is correct. Kaushiki, 4 is correct. Kaustubh, 4 is correct. Okay, Abhinil, this is the answer of number 4, right?
Yes, sir.
Check it again.
Okay, sir.
Aditya, check number 4. Devopriyo, 4 is correct. Bhargav, 4 is correct. Okay, so somebody is raising their hand. No. Okay. Okay, let me start with number 4. It's given that the product of two numbers is 6760. Yes, the band number 4 is correct. And their HCF is 13. We need to find out how many such pairs can be formed. Okay, let us start.
So I can wait for 1 minute.
1 minute. Quickly solve.
Okay, sir.
Aditi, check number 4. Yes, Abhinil, 4 is correct. Okay, I'm starting with number 4, everyone. Pay attention. They have given that HCF of two numbers is 13 and the product is given 13. Our product is 6760. So again, everyone, I can take the two numbers. Let the two numbers be. Let the numbers be 13A and 13B. Okay. So everyone, 13A multiplied by 13B is given as 6760. This implies A multiplied by B is equal to 6760 divided by 13 into 13. Okay. This will give us 13 times. This will go by 520, I guess. And 13 times 40. So everyone, product of AB is equal to 40. Okay. And since they don't have any other common factor, 13 is the highest common factor. I have to find out two numbers such that their product is 40 and their GCD is 1. So let us see 40 can be written in how many ways? It can be written as 1 into 40 ways, 1 into 40. It can also be written as 2 into 20. It can also be written as 4 into 10. It can also be written as 5 into 8. Okay. Now I need to find out those pairs where the GCD is equal to 1. So everyone, should I take 2 into 20 and 4 into 10? No, right? 2 into 10 and 4 into 10, 2 into 20 and 4 into 10 is discarded. Okay. So these are the only correct choice. 1 into 40 and 5 into 8. So two such pairs. Is it clear to everyone? Okay. Yes. Anybody having any doubt, you can raise your hands and ask me. Yes, Deopriya, tell me.
Sir, if we consider means it is said two possible outcomes and 40 into 1 can also be one outcome and 8 into 5 can also be one. Then 4 should not be.
Yes. The thing is, you see, for 1 comma 40 and 40 comma 1, you are getting the same pair.
Yes,
Yes or
yes.
no?
Yes,
Same pair of
yes.
numbers. Are you getting?
Yes, yes.
So they are not different. Understood? They are same only.
Okay,
Okay.
sir.
The question clearly mentions that we need to find out the number of pairs that can be found. Only pairs. If they had written number of such ordered pairs, okay,
Yes,
then you
sir.
have to take two different cases. Understood?
Okay, sir. Yes, sir.
Okay.
Okay, sir.
And Snehatara, we are talking only about natural numbers over here. Okay. Product of two such numbers and their HCF is talking. Is it clear?
Okay, sir.
Okay. So next, let us continue. So our next topic is HCF by difference method. HCF by difference method. How can we find out the HCF by difference method? Okay. Number one, let A and B be two numbers. Let A and B be two numbers. Okay. And their HCF be and their highest common factor be capital H. Okay. Sampurna and Samriddhi, you people understood the previous one, question number 4.
Yes, sir.
Okay. And their HCF PH. Okay. So there exists some integers x and y. Okay, such that A will be equal to h into x and B will be equal to h into y for some x comma y belongs to integers. Okay. That is for some x comma y belongs to integers. A will be equal to h into x and B will be equal to h into y. Okay. Now see everyone, if I take the difference A minus B, it will be equal to hx minus hy. If you take h common, you will get x minus y. Okay, can you people see that this h is also a factor of their difference? Right, tell me everyone. This implies h is also a factor of their difference. A factor of their difference. A minus b. Okay. And if x minus y is equal to 1, sometimes what will happen that x minus y will be equal to 1 only. Okay. Then HCF will be equal to mod of the difference. Okay. HCF will be equal to mod of their difference. Number 2, if A, B, and C are three numbers, if we talk about three numbers, if A, B, and C are three numbers, okay, then you will see that A minus B is equal to H into X minus Y and B minus C is equal to H into Y minus Z and C minus A is equal to H into Z minus X. Okay, you will see that H is again the common factor of their differences also, right? So HCF can also be found. So HCF can also be found, can also be found by taking the HCF of the differences, by taking the HCF of A minus B, comma B minus C, and C minus A. Very simply. Okay, I'll give you an example how it can be helpful to us. For example, I want to find out HCF of 85, 119, and 187. Okay, so everyone, what is the difference 119 minus 85? 119 minus 85 will be equal to 34. Okay, I need to find out the highest common factor. So you see everyone, 117 minus 119, sorry, 187 minus 119 is also equal to 68. Okay, next. Okay, so everyone, this 34, yes. Okay, so everyone, 34 can be written as 1 into 34 or 2 into 17. Okay, and further. So everyone, we have to find out the highest common factor. So what do you think? Does 34 divides all three of them? Does 34 divides all three of them? What do you think? No, right?
No, sir.
34 is an even number and these are odd natural numbers. Okay, so 34 cannot be your HCF. Next, so we'll move on to 17. Does 17 divides all three of them?
Yes, sir.
Okay, so 17 is your answer. So HCF is equal to 17. Okay. Just have to find out the highest common factor of their differences. Okay, just find out one or two differences and take the highest common factor. Okay, so you people try out with this problem. Find the HCF of, find the HCF of 48, 90, and 120. Okay, try out by difference method. 48, 90, and 120. So once you have done it, send your answers. Yes, Deopriyo, right answer. Snehadra, right answer. Bhargav, right answer. Try it out by difference method only. Okay, everyone. Yes, everyone is correct only. Kaustav, Abhishek, Abranil, Sampurna, Samriddhi, everyone is correct. Aditi, you're correct. Aman, right answer. Pashani, Rupkatha, is correct. Okay, so everyone see, I do it by difference method. So let us find out the differences. Yes, Samriddhi, right answer. 90 minus 48 will give us 42, and 120 minus 90 is equal to 30. You will see that the HCF of 30 and 42 is equal to 6. And see, 6 divides all of them. Okay, therefore HCF is equal to 6. Very simple. Just find out two of the differences, you will be done. Okay, next. The greatest number, the greatest number which will divide, the greatest number which will divide A, B, and C, leaving the same remainders, leaving the same remainder in each case. The greatest number which will divide A, B, and C, leaving the same remainder in each case. In each case will be the HCF of, will be the HCF of mod of A minus B, comma mod of B minus C, comma mod of C minus A. Okay. So I'll show you the proof. Okay. But before the proof, let us give an example. Let us take an example. Then I'll show you the proof. For example, the greatest number that will divide that will divide 410, 751, and 1030, leaving the same remainder. Leaving the same remainder in each case. Okay, will be. Leaving the same remainder in each case will be 751 minus 410. Let us take their differences. After differences, we have to take their HCF also. 751 minus 410 will give us 341. Next, 1030 minus 751 is equal to 279. And 1030 minus 410 will be equal to 620. So everyone, if I want to find out the HCF of these two numbers, what is the HCF of these two numbers? Tell me. 341 and 279. What is the HCF? Is it coming 31? Tell me.
Yes, sir.
Or
Yes, sir.
what you can do is you can further take the differences. I want to find out the differences of these three numbers. I mean, I want to find out the HCF of these three numbers. So let us again take their differences. Okay. The difference of these two numbers is equal to 62, and the difference of these two numbers is equal to 341. Right. And you will see that 62 is equal to 2 into 31, and 31 divides 341. So you see the required number. The required number is 31. Okay. Now everyone, you divide 410 by 31. What is the remainder? See, everyone, what is the remainder when 410 is divided by 31? How much are you getting? Are you getting 7? Tell me. 410 divided by 31. Are you getting 7? Tell me.
Yes.
410. Okay, remainder is 7. 751 by 31. Are you getting the remainder 7 only? Just check. Tell me. How much are you getting? You'll get the same remainder 7.
7.
And same with 1030 also. Okay. Now let us see the proof. Okay. So see everyone. Let us say H is the greatest common divisor. Okay. Or no, let h be the greatest number. Let h be the greatest number. Let h be the greatest number that divides A, B, and C. That divides A, B, and C, giving the same remainder R. Giving the same remainder R. Okay. Let us say H is the greatest number that divides A, B, and C, giving the same remainder R. Okay. So I can say by division algorithm, I can say A is equal to HX plus R. Right, tell me everyone. Dividend is equal to divisor into quotient plus remainder. Similarly, B will be equal to HY plus R and C will be equal to HZ plus R. Okay. So now you find out the differences. What is A minus B? A minus B is equal to H into X minus Y. B minus C is equal to H into Y minus Z. And C minus A is equal to H into Z minus X. Okay. So what is the highest common divisor, everyone? Highest common factor? Can you people see? What is the highest common factor of A minus B, B minus C, and C minus A? Tell me.
H.
H only. Hence proved. So highest common factor of mod of A minus B, comma mod of B minus C, and mod of C minus A. This will be equal to H only. Okay, hence proved. Next, another theorem that largest number that divides X, Y, and Z, leaving remainders, leaving remainders leaving remainders P, Q, and R will be HCF of X minus P, comma Y minus Q, comma Z minus R. Okay. So again, let us see the proof. Proof is very simple. Everyone, let us say that the largest number. Let the largest number be H. Let the largest number be H. Okay. Then can I say that X will be equal to HA plus P by division algorithm? Y will be equal to HB plus Q, and Z will be equal to HC plus R. Okay. Acha. So you people tell me what is the HCF of X minus P, Y minus Q, and Z minus R? What is it? Tell me. What is the HCF of X minus P, Y minus Q, and Z minus R? Yes. Aditi, tell me.
Sir, H.
H only. Hence proved. If there is anyone having any doubt, you can ask me. Tell me. Kaushani, is it clear? Kaushani, Pronil, Jabayan, Abhishek,
Yes, sir.
Deopriyo. Everyone
Yes.
understood?
Yes, sir.
Kaushiki, Sampurno, Samriddhi. Is it clear?
Yes, sir.
Snehadra.
Yes, sir.
Okay. Samriddhi 1, is it clear? And
Yes, sir.
okay. If there's anyone having any doubt, you can ask me. It's very simple. Okay, next. Another theorem. What is the smallest number? Smallest number which when divided by x, y, and z, which when divided by x, y, and z, living remainders, living remainders p, q, and r, living remainders p, q, and r, respectively, respectively, and x minus p is equal to y minus q is equal to z minus r is equal to some constant k will be will be LCM of LCM of x, y, z minus k. Means if you remove the smallest number, since I have taken the smallest number, that's why I have taken least common multiple. Okay, everyone. If you find out any number instead of smallest number, if it was given any number, okay, any number which when divided by x, y, and z, leaving remainders p, q, and r respectively, such that x minus p is equal to y minus q is equal to z minus r is equal to k, will be only a multiple. Okay, not LCM. LCM is when you want to find out the smallest number. Okay, but if you find out any number, then it will be of the form a multiple of x minus x, y, z minus k. Let us see the proof. Again, the proof is very simple. Okay, so mm, so everyone, uh, I can say that h is equal to then. Okay, let us say that let the number be h. Let the number be h. Okay, it is divided by x. So I can say that h is equal to xa plus p. Okay, remainder is equal to ha plus h is equal to, I mean, the number is equal to xa plus p. Also, everyone, what is the value of p? P is equal to x minus k, right, everyone? So I can substitute. This is also equal to xa plus x minus k. Okay. So everyone, this will become x into a plus 1 minus k. Similarly, h can also be written as y into b plus 1 minus k. And h will also be equal to z into c plus 1 minus k similarly. Okay. So see everyone, h is the number which are living the same, which is giving the same remainder when it is divided by x, y, and z. Right. So see, I can say that h is a least common multiple of x, y, and z minus k. Hence proof. Are you people getting? See the form of h. H is equal to x into a plus 1 minus k. H is also equal to y into b plus 1 minus k. And h is also equal to z into c plus 1 minus k. Okay. So I can say that h is equal to the least common multiple of x, y, and z minus some constant k. Okay. If there's anyone having any doubt, you can ask me now. Okay, next, we can do another problem. Question number 6. question number 6, everyone. Find the least number. Find the least number which when divided by which when divided by 6, 15 and 17 leaves a remainder 1 in each case, leaves a remainder 1 in each case, but when divided by 7, but when divided by 7 leaves no remainder. But when divided by 7 leaves no remainder. Question number 7. Find find the least number of find the least number of equal sized square tiles. If Bhargav, your answer is correct, which can be fitted in a rectangular field in a rectangular field whose sides are 248 meter and 284 meter. Solve. Yes, Aditi, you want to say something? Yes, Jyopriya, right answer. Pranil, right answer. Sampurno, Samriddhi, your answer is correct. Okay, let me start. Yes, Kaushali, no, Aman, your answer is correct. Okay, question number 6. We need to find out the least number, which when divided by 6, 15 and 17, leaves a remainder 1 in each case. Aditi, check your answer again. Abhishek, right answer. Samriddhi, check your answer again. Kaushani, your answer is correct. So everyone, we need to find out the least number, which when divided by 6, 15 and 17, leaves the remainder 1. Okay. So first of all, you find out the LCM of 6, 15 and 17. LCM of 6, 15 and 17 is equal to 510. Very simple. You people can calculate. Okay. Now, so everyone, I can say that the number is of the form. The number. So the number is of the form. 510k plus 1. Okay. LCM is equal to 6, 15 and 17. LCM of 6, 15 and 17 is equal to 510. So the number is of the form 510k plus 1. Okay. So for k equal to 1, the number is 511. Is it divisible by 7? Yes, which is divisible by 7. So 511 is your answer. Therefore, the number is 511. Required number is 511. Done. Very simple. Okay, try out number 7. Yes, Aditi, have you understood? Aditi, Samriddhi, is it clear?
Yes, sir.
Okay. Dev, okay. Somebody is raising the hand. Yes, Kaustav, tell me.
Sir, I did not understand the sum because why should we multiply? Why should we find the LCM?
Because we need to find out the least number that is divided by 6, 15, and 17. Okay. Are you getting?
Yes, sir.
So they should be divisible. I mean, that number minus 1 should be the LCM of 6, 15, and 17. Yes or no? Because it should give
Yes,
us the
sir.
remainder 1. Now are you getting why are we finding LCM of 6, 15, and
Uh-huh.
17? Yes, Abhinay will tell me.
So just explain me the second line that you have written.
Second line, which
No,
one?
sir, the second line that you have written of this.
Oh,
The number is of the form that.
yes. LCM is equal to 510, right? It
Yes,
is
sir.
divisible by all three of them, 6, 15, and 17.
Yes, sir.
Plus, the remainder has to be 1, right?
Yes, sir.
So that means the number should be of the form 510k plus 1, right? It should give us the remainder 1. You see, when you divide this number by 6, you'll get the remainder 1. When you divide it by 15, you'll get the remainder 1. When you divide it by 17, you'll get the remainder 1 only. Are you getting? So
Okay,
that
sir.
is why the number is of the form 510k plus 1.
Okay. Thank you, sir.
Yes. Bhargav, tell me.
Sir, for question 7, does it require for the tiles to be exactly fit within the rectangular field?
Exactly fit. Exactly. It has to
Like
exactly
no
fit.
space can't be left. No
No
space can be
space.
left.
Yes, yes. No space has to be there. Okay.
Okay.
So everyone, should I start? Number 7. Let's see. Somebody has given the answer. Okay. Yes, Deopriyo, check your answer again. Okay. So everyone, should I give a hint for 7? Yes, 7. Koshani, your answer is correct. Tell me, should I give a hint, everyone, for 7?
No,
Like
sir.
how you have to proceed? Yes, someone right answer. Deopriyo, check your answer again. Yes, Mahadara, right answer. Kaustav, right answer. Sampurno and Samriddhi, check your answer again. Okay, so everyone, let us start. We need to find out the least number of equal size square tiles which can be
Just a
fitted.
minute, sir. I'm sending.
Okay, send. Abranil, right answer. Deopriyo, check your answer again. Devan, check your answer again. Sampurno and Samriddhi, too, check your answer again. Aditya, right answer. Devan, right answer. Bhargav, right answer. Okay, let us start. So basically, there is a rectangle. Everyone pay attention. They are asking us what's the least number of square tiles, equal sized square tiles. Samriddhi, one, check your answer again. Least number of equal sized square tiles that can be fitted in a rectangular field of whose sides are 248 meter and 284 meter. So everyone, this is the rectangular field we are talking about. This side is 284, this side is 248. So what are they asking? Everyone pay attention. They are asking what is the least number of squares you can fit. Okay. So everyone, if I take 1 meter square, if I take 1 meter square, okay, equal sized 1 meter squares, okay, then how many squares we'll need? We'll need 284 into 248 squares, right? Tell me, are you people getting this logic? If I take 248 into 284 meter, I mean 248 into 284 squares, okay. Now tell me, in which case it will be the minimum, by taking 1 meter square or by taking 2 meter squares? Tell me. In which case I'll be using less number of tiles. Tell
Sir,
me.
2.
In case of 2 meter squares, I'll use less number of tiles. Can you people realize this? Tell me. Sampurno, Samriddhi, Aditi, are people getting?
Yes, sir.
Okay, in case of 2 meter squares, okay, it will be the least. Okay. Right, Samriddhi, one, are you getting?
Yes,
Deopriyo,
sir.
are you getting?
I made a silly mistake. I'm sending the answer again.
Okay, okay. Deopriyo, Abhishek, are people getting? Pronil, are you getting?
Yes, sir.
Okay,
Yes, sir.
okay. Now see, whenever you are fitting the squares, okay, the length of the square and the breadth of the squares should divide both length and breadth of the rectangle. Are you getting? So in order to have the least number of squares, we have to find out the square with the highest common factor of 248 and 284. Are you getting? That means that will divide both 248 and 284. Can you people understand? Tell me why I'm
Yes.
finding out the HCF of 248 and 284. This is the side of the square. Okay. It should divide. I mean, the length of the square should divide the length of the rectangle. The breadth of the square should divide the breadth of the rectangle. Okay. So in order to have the least number of squares, we need to find out the highest common factor of 248 and 284 is the side of the square. Okay. So what is the highest common factor of 248 and 284? How much are you getting, everyone? 4.
Yes, sir.
Yes, sir.
This is the side of the square. 4 meters. Therefore, number of tiles, number of square tiles will be equal to 248 into 284 divided by 4 into 4. That would give us 4402. Remember. So if there's anyone having any doubt, you can ask me. Pronil, is it clear?
Yes, sir.
Okay. Next. So everyone, over here I had given one theorem. Okay, I have told you that I'll prove it later. Okay, I have told you that in the beginning, I had told you that if n is equal to LCM of A and B, then n is equal to AK, n is equal to BL, Okay. Over here, GCD of K and L should be equal to 1. Right. So let us see the proof. That is, if n is equal to LCM of A and B, n is equal to AK, n is equal to BL. Okay, for some K and L belongs to integers. I need to prove that GCD of K and L will be equal to 1. Okay, everyone. Let's start. Okay, let us see the proof. So if n is equal to LCM of A and B, n is equal to AK and n is equal to BL, for some K belongs to L, for some K and L belongs to integers, prove that GCD of K and L is equal to 1. Okay, let us see the proof. So everyone see. Okay, let GCD of K and L be equal to D. Okay, I proved that D is equal to 1. Okay, everyone. Achha, so everyone, if n is equal to AK, so can I say K is equal to n by A and L is equal to n by B? Right, everyone. What does it implies? This implies GCD of n by A, comma n by B should be equal to D. Achha, everyone, GCD of fractions, HCF of fractions is equal to HCF of numerator divided by LCM of denominators. Okay, this is the value of D. So HCF of and an n, what is the value of HCF of and an n? Tell me, everyone. What is the highest common factor of and n? Yeah, what is the LCM of A and B? Raise your hands. What is the LCM of A and B? Tell me. It's given in the theorem, right?
It's N.
n is equal to n equal to LCM of A and B. So see, everyone, are we getting 1? This implies D is equal to 1. Hence proved. Okay. So whenever you express n is equal to AK and n is equal to BL, okay, GCD of K and L will be equal to 1. Next, another question. Question number 8. What is the sum of the digits? What is the sum of the digits of the least number? Of the least number, which when divided by? Which when divided by 15, 25, and 27? Which when divided by 15, 25, and 27 leaves a remainder. Leaves a remainder 9 and is also completely divisible by 11. And is also completely divisible by 11. Solve. Option A, 15. Option B, 16. Option C, 17. Option D, 18. Solve. Once you have done it, send your answers. Okay, Devapriya, check your answer again. Aman, right answer. Vashali, your answer is correct. Abhishek, check your answer again. Okay, everyone, let me start.
Sir, please wait.
Okay, solve quickly. Tony, your answer is correct. Abhishek, your answer is correct. Snehatara, your answer is correct. Kaushiki, your answer is correct. Jyopriya, your answer is correct. Rupkotha, your answer is correct. Devan, your answer is correct. Aditi, your answer is correct. Samriddhi, 1, your answer is correct. Okay, so everyone see, by looking at the sum, can you people understand it is written that we need to find out the sum of the digits of the least number, which when divided by 15, 25, and 27. Okay, the least number, which when divided by 15, 25, and 27, leaves a remainder 9 and is also completely divisible by 11. Okay, I would have directly given the answer as option D, 18. Okay, everyone. Why? Because you see, that number leaves a remainder 9 when divided by 27. That means, can I say that the number is divisible by 9? Tell me, yes or no. Can I say that the number is divisible by 9? Yes or no? Tell me, everyone. Whatever your required number is, I don't know what may be the number, that number is divisible by 9. And if that number is divisible by 9, that means the sum of the digits should also be divisible by 9. And among the options, in which case the sum of the digits is divisible by 9? Tell me. Option D.
HG.
So option D is your correct answer. Okay. Are you people getting how you can solve this sum within 5 to 10 seconds? Okay. But anyways, in the exam, they can also ask you the exact number instead of the sum of the digits. Let us understand how can we find out the sum exact number. We need to find out the least number which when divided by 15, 25, and 27 leaves a remainder 9. Okay. So can I say that the number is of the form Is Sampurna and Samriddhi, are you people getting?
Yes, sir.
Okay. So first of all, you find out the LCM of 15, 25, and 27. 25 and 27. This will be equal to 675. So I can say that the required number is of the form. The required number is of the form 675k plus 9. Okay. It's a multiple of 675 plus 9. Remainder is 9. Okay, everyone. After this, what you do? You take 9 as common. You get 75k plus 1. Now see, you can understand that this number has to be divisible by 3, right? This number has to be divisible by 3. That means for some k equal to 1, 2, 3, something, it has to be divisible by 3. Okay,
So why?
wait a minute. The remainder is 9. Actually, no, completely divisible by 11. No, sorry. This number has to be divisible by 11, right? This implies 75k plus 1 should be divisible by 11. Right, Aditya, are you getting?
Yes, sir.
Should be divisible by 11. Okay. So what I'm going to do is I'll substitute k equal to 1, 2, 3 to understand whether it is divisible by 11 or not. Okay. For k equal to 1, it is not possible. 76. You can try out with k equal to 2. For k equal to 2, it is 151. Not possible. N is equal to 151 into 9. So not possible. For k equal to 3, n is equal to 75 into 3. 75 into 4. Sorry, 75 into 3. That would give us 225 into 9. Not possible. For k equal to 4, 75 into 4. That is 300 into 9. Not possible. For k equal to 5, n equal to 375 into 9. Again, not possible. Okay. For k equal to 6,
Sir, we should plus 1.
So yes, sir. We should plus one.
we should add 1. Oh,
Yes,
I'm
sir.
missing 1. Wait a minute. Oh, yes. Over here, it should be 226. Over here, it should be 301. Over here, it should be 376. Oh, yes, yes, yes. Now it's fine. But still, I don't think so. 376 is divisible by 11. 301 is also not divisible by 11. 226 is also not divisible by 11. For k equal to 6, n is equal to 451 into 9. Is it divisible by 11? Tell me, 451?
Yes, sir.
Yes, sir.
Yes, so this is your correct number. Okay. And when you multiply, n will come as 4059. Okay. So sum of the digits is equal to sum of digits is equal to 4 plus 5 plus 9. That's 18. Okay. If there's anyone having any doubt, you can ask me now. Tell me, Kostov, you want to say something?
Sir, I did it very differently. I used modular arithmetic.
Okay. It's correct then. Okay. Tell me, Aditya, have you understood?
Yes, sir.
Okay. That Kotha, have you understood?
Yes, sir.
Okay, next. Another topic I'm going to discuss fundamental theorem of arithmetic. The fundamental theorem of arithmetic. That is, every integer, every integer greater than 1, every composite integer, every composite integer greater than 1 can be expressed as a product of primes. As a product of primes. Okay, that is n can be written as p1 to the power alpha 1 into p2 to the power alpha 2 into p3 to the power alpha 3 dot pk to the power alpha k. Okay, where p1, p2 up to pk are prime numbers. Okay, now what is written over here? This is the prime factorization of n. Prime factorization of n, where p1, p2 up to pk are prime numbers. Where p1, p2 up to pk are prime numbers. Okay, next, number of divisors of n. Okay, we did it last year also. Number of divisors of n. So everyone, if n is equal to p1 to the power alpha 1 into p2 to the power alpha 2 into pk to the power alpha k, then number of divisors of n, number of divisors of n will be equal to alpha 1 plus 1. Everyone remembers? Tell me, those who did the class last year from the beginning, alpha 3 plus 1 up to alpha k plus 1. Okay, let us see the proof. So first of all, I'll give you an example, then I'll show you the proof. For example, so in example only there is a proof. Okay, for example, let us say 14112. Okay, can anyone tell me the factorization of 14112? Tell me. Can anyone tell me the factorization quickly? Factorize and tell me. Raise your hand. Tell me the prime factorization of 14112. Yes, Aditi, tell me. How much are you getting?
So 2 to the power 5 into 21 to the power 2.
That is 3 to the power 2 into 7 to the power 2, right? Prime factorization, completely factorize. Okay, Aditi. Okay. Achha, so everyone, what are the factors of 2 to the power 5? Okay, let us make a set. Factors of 2 to the power 5. This will be equal to 2 to the power 0, 2 to the power 1, 2 squared, 2 cube, 2 to the power 4, and 2 to the power 5. There are in total 6 factors, right? What are the factors of t squared? To the power 0, to the power 1, t squared. And what are the factors of 7 square? 7 square is 7 to the power 0, 7 to the power 1, 7 squared. Okay. So everyone, consider that there are 3 shops in front of you. Over here, only factors of 2 are available. Over here, only factors of 3 are available. Over here, only factors of 7 are available. Okay. So everyone, if I want to write down the factor of 14112, if I want to write down the factor of 14, 1 and 112, I'll select any one item from this shop, right? And I'll select any one item from this shop, and I'll select any one item from this shop. And if I multiply, I'll get the factor of 14, 112, right? For example, you have selected 2 square over here, and you have selected 3 to the power 1, and you have selected 7 to the power 1. Tell me, is it a factor of 14, 112? Tell me, is it a factor of 14, 112? Yes or
Yes.
no?
Yes, sir.
Okay.
Yes, sir.
So everyone, what is the number of ways in which we can choose, in which we can choose a factor of 2 to the power 5? It will be equal to 5 plus 1, right or not? Tell me everyone. Either you will select 2 to the power 0, or you will select 2 to the power 1, or you will select 2 square, or you will select 2 cubed, or you will select 2 to the power 4, or you will select 2 to the power 5. So that gives us 5 plus 1 choices. Are you people getting? Yes or no? Tell me. Konil, Brunil, are you people getting?
Yes,
Aditi,
sir.
Yes, sir.
Aman, Abhishek, Aditya, Bhargav,
Yes, sir.
Debayan,
Yes,
are you
sir.
people getting?
Yes, sir.
Yes,
Okay.
sir.
Deopriyo, Kaushani, Sampurna, Samriddhi, Rupkotha, Kaushiki, are you people getting? Samriddhi 1 and
Yes,
Snehatara,
sir.
are you getting?
Yes, sir.
Kaustav, are you getting?
Yes, sir.
Okay. Similarly, in how many ways we can select a factor of 3 squared? Tell me. It will be 2 plus 1. And similarly, if I want to select a factor of 7 squared, it will be 2 plus 1. Okay. So are the people able to visualize the total number of factors? Therefore, the number of factors is equal to number of factors is equal to 5 plus 1 into 2 plus 1 into 2 plus 1. That is alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1. Done. Okay, if there's anyone having any doubt, you can ask me. This gives us 54. Done. 6 into 9, 54. Okay. So everyone, let us do one problem on this. Okay, one last problem. Question number 9. After this, okay, everyone will give the test, right, today? Tell me.
So what test?
Yes, sir.
What test? Somebody asked what test? Who say?
Sir, us.
Oh, acha, Sampurna Sami. Acha, no. This test is not for you people, but if you want to give, you can give. It is based on class 9 full syllabus.
Okay,
Okay.
sir.
Find the number of. Acha, wait. Consider a number. Consider a number n is equal to 37800. Part 1. Find the number of devices of n. Part 2. Find the number of odd devices of n. Part 3. Find the number of even devices of n. Part 4. Find the number of ways in which n can be written, in which n can be written as a product, as a product of two numbers or two natural numbers. Yeah, once you have done it, keep sending your answer. Yes, Sampurna Samriti, you are saying something?
Sir, where can we give the test?
It can be given online. You want to give?
Yes, sir.
Okay. Then wait for some time. After this sum, I'll send one link in the group. Okay. You have
Okay,
to
sir.
log in and send your email ID. Okay. So
Okay,
that
sir.
I can register.
Okay, sir.
Okay. Now both of you give on two separate devices. Okay. Don't give as one. Okay.
Yes, sir.
And in different rooms also. It would be
Yes,
better.
sir. Yes, sir.
Yes. Aditi, part one is correct. Abhunil, part one is correct. Deopriyo, all your answers are correct. Kaustav, part one, two, and three are correct. Abhunil, part two is correct. Abhishek, all are correct. Kaustav, part four is correct. Aditi, part two is correct. Check part three. Snehadra, all are correct. Samriddhi, one, part one is correct. Abhunil, part three is correct. Rupkatha, all are correct. Samriddhi, this is the answer of part two or part three. Oh
Part
no.
3 I sent by mistake.
Okay. Yes. Aman, all are correct. Kaushani, all are correct. Oh no, Kaushani, there is a slight mistake in part one. Bhargav, all are correct. Samriddhi, part two is correct. Yes, Kaushani, now it is correct. Aditi, part three is correct. Oh no, Aditi, there's a mistake in part three. Okay, I think I can start. Let us start, everyone. Number is
So,
there.
so wait, sir, I'm sending my answer.
Send. Aditya, check part one. Part two is correct. Check part three. Debaran, all are correct. Okay, let us start. Aditya, is it done? Okay,
So I can't.
let us start. So basically, first of all, factorize 37,800. Yes, part 4 is correct, Abhunil.
Okay, sir.
N will be equal to 2 to the power 4 into 3 to the power 4 into 5 cube into 7 square, I guess. I don't know. Right, how much you got, everyone? I mean, after factorization. 2 cube, 2
Yeah,
cube, 2 cube.
everything one less.
Yes, 2 cube into 3 cube into 5, 5 square into 7 to
Seven.
the power 1.
Yes, sir. 7 to 1.
Yes. So part 1, number of devices. Number of devices of n will be equal to 3 plus 1 into 3 plus 1 into 2 plus 1 into 1 plus 1. That gives us 96. Next, number 2, number of odd devices. Number of odd devices of n. Number of odd devices of n. This will be equal to. So everyone, should I select anything from the first shop? Tell me. If I select any one item from the first shop, the factor becomes even, right? So I shouldn't select anything from the first shop. I should select everything from the remaining three shops. So it will become 3 plus 1. Sampurna and Samriddhi, are people getting?
Yes, sir.
Into 2 plus 1 into 1 plus 1. Right. Aditi, are you getting? Aditi, Kaushiki, are you people getting?
Yes, sir.
Okay. That gives us how much? 24. So everyone, if the number of devices is 96, number of odd devices is 24. So what is the number of even devices? Tell me, Sampurna and Samriddhi, number of even devices will be from the total. I need to subtract, right? 96 minus 24. That is 72. Okay. Last part, part 4. We need to find out in how many ways 37800 can be written as the product of two factors. First of all, 37800 can be written as 1 into 37800. Then it can be written as 2 into 18900. It can be written as 3 into 6300. It can be written as 4 into, sorry, not 3 into 6300, 3 into 12600. Then it can be written as 4 into 9625, I guess. Okay. Dot, 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 dot. Lastly, somewhere, you keep on writing like this. You keep on writing like this. Okay. I think 9450.
Yes, sir. 945.
You keep on writing like this. Somewhere you will get 9450 into 4, then 12600 into 3, then 18900 into 2, and lastly 37800 into 1. So what do you think? How many times I have written? Tell me. How many times I have written? Can someone tell me? Raise your hand. How many times I have written this? Tell me. Yes, Aditya, tell me how many times I have written?
14.
14? Why 14? What
No,
are
I mean,
these?
I don't know. That's it.
1, 2, 3, 4. Then after that you'll get 5, then 6, then 9450, then 12600, 18900, 37800. What are these? Yes, Somriddhi, tell me.
96.
Yes, I have written 96 times because there are 96 factors. Are you getting? Tell me, Aditya.
How?
Because all these are factors of 37800, right? Tell me.
Yes, sir.
All these are consecutive factors in ascending order, right? Can you see? So I have actually written 96 times. Okay. Are you able to understand? Tell me.
Yes, sir.
Okay. Kaushiki, can you understand?
Yes.
Sampurna and Samriddhi, can you understand? Okay.
Yes, sir.
but the first way to write and the last way to write is same, right?
Yes, sir.
Second way to write and second last way to write is same. Okay. So that means I need to divide it by 2. So the number of ways is equal to 96 divided by 2, which is 48. Okay, tell me. Aditi, is it clear? Aditi, Sampurna, Samriddhi,
Yes, sir.
Tonil, is
Yes.
it clear?
Yes, sir.
Okay. Okay, so everyone, that's all for today. Okay, those who are taking the test. Yes, Devapriya, tell me, you want to say something?
Yes, sir. I have a doubt. Like means we can find the number of odd factors. Then can we find the number of even factors earlier and then number of odd factors?
Yes, we can find out the number of even factors also first, and then we can find out the number of odd factors.
Sir,
Should I
how?
show?
Yes, yes.
Okay. Okay, so method 2 of number 3. I want to find out the number of even factors. So everyone pay attention. From this shop, wait a minute. There are 3 shops, right? No, 4 shops. 2, 3, 5, 7. In the first shop, how many items are there? 4, right? Then 4, then 3, then 3. Now there.
So three.
Three, three, two,
I
and three.
think
Wait a minute. Let me see. Let me see. No,
step two.
4, 4, 4, 4, 3, and 2.
Yes,
Okay.
yes.
Now, now see, Devapriya, I want to find out an even factor. Okay. Over here, the items are 2 to the power 0, 2 to the power 1, 2 square, 2 cube, 2 to the power 4, right? No,
Yes.
sorry, 2 cube and only 2 up to 2 cube. So, Devapriya, from the first shop, from the first shop, if I select 2 to the power 0,
Yes.
only 2 to the power 0, will I get an even factor?
2 to the power 0. No, sir.
No, that means I don't need to select 2 to the power 0, right? I
Yes.
need to select the remaining items,
Yes.
right? So the remaining items can be selected in how many ways?
6.
Why 6? There are 3 items only, right?
Oh, I thought number of ways. Okay.
Number of ways, I asked number of ways only. In how many ways we can select these 3 factors? 3 only.
Yes, yes. 3.
So it will be equal to 3 into 4 into 3 into 2. How much are we getting? Tell me.
72.
72. Is it clear?
Oh, okay, sir.
You
Yes, sir.
Yes.
just don't need to select 2 to the power 0. Yes.
Okay, sir. Thank you, sir.
Yes. Okay. So those who are giving the test today, okay, you can stay back. Others can leave. Thank you, everyone. Okay. Those who are giving the test, you can turn your cameras on. Then I'm going to send the link. Okay. Those who are giving the test, you can turn your cameras on. Yes, Devapriyo, you can leave. No problem.